So, hello friends. In this Leetcode Contest, we are going to discuss three problems. The first three problems, okay. And our first problem is find minimum operations, make all divisible by three. Okay. Basically, we have been given an integer array nums. Okay. We have been given an integer array nums, and in one operation, you can either add or subtract one from any element of nums. Okay. You have to return the minimum number of operations to make all nums divisible by 3. For example, if you see, you have taken input nums array. Okay. So for one making divisible by 3, it you must add 1 or subtract 1. But you can perform operation only one time on a single integer. Okay. So if you add 1 to 1, it will be 2. So 2 is not divisible by 3. So you must subtract 1 from 1. So it will make 0. As 0 is divisible by 3, so our operation will be 1. Okay. Now we go on second. Uh, so our next number is 2. If we add 1 to 2, it will be 3. So 3 is divisible by 3. So our next operation is 2. Okay. Now 3. We will not perform any operation on the 3 as it is already divisible by 3. Now 4. You will subtract 1 from 4. Okay. So basically, hey, what approach I have used? You can see here. I have iterated through the array, traverse array for looking for zeros. Okay. Then I have identified the remainders for each element in the array. I calculate the remainder when divided by 3. This is remainder count, remainder count, and it is for num in nums. Basically, counts the remainder, counts of remainder 0, 1 and 2. This is basically counts of remainder 0 and 1 and 2. Okay. So, and this is now we are counting the remainders. Count remainders. So basically, if remainder are 0, element needs 0 operation. Okay. Remainder. I have incremented the remainder count, as you can see, making it more precise for you to understand. Operations. So basically, remainder 0 element needs 0 operation. If remainder is 0, element needs 0 operations. Okay. Now, if remainder is 1, element needs 1 operation to become 0. If remainder is 1, element waiting. If remainder is 1, element need 1 operation to become 0. Means you can subtract 1. Okay, is that clear? Now next. If remainder is 2. Element needs one operation to become 0. Okay. Element needs one operation to become 0 means you must add 1. Is that clear? You must add 1. Yes. So I have just counted the remainder for each operation by 1. Now this one. As you can see in this, operation equals to remainder count 1 plus remainder count 2. This. If you have been given an element like, for example, you can take 7 or, yes, you can take 7. 7 mod 3. 7 mod 3 equals to what? Equals to 1. So you must either subtract. So our remainder is 1 here. So you can read the second line. Okay, you must subtract 1 from 7. If you if you subtract 1 from 7, it will be what? 6. So 6 mod 3 is what? Equal to 0. Okay. So this is the basic approach I have used here. I think you must have been understand this approach. Let's try to submit. It's giving runtime error for I. Hi. Yes, I got the error. I have used it I. It's now mod 3. Now let's try to run the code. Yeah, it's giving correct output. Now let's try to submit. Yeah, it's been accepted as you can see here. So now let's move on to our next problem statement. Okay, I was able to solve only 3 questions. So I will be able to explain only 3 only. No worries. Now let's move on to next one. Hmm. Our next question is minimum operations to make binary array elements equal to 1. And it's the first part. Okay, simple. It's just a simple question. Yes. So basically what? You have been given a binary array of nums. Binary array of num means it's an array in which all the numbers are in the form of either 0 or either 1. Okay. So you can do following operation on the array any number of times. You can do the operation any number of times. Okay. But there is a condition. You have to choose any 3 consecutive elements from the array and flip all of them. Means हमें क्या करना है? हमें means what we have to do? Any 3 consecutive elements like 0, 1, 2 or what or 1, 2, 3. These 3 consecutive elements or 3, 5, 3, 4, 5. Okay. So you must have choose only 3 consecutive elements from the array and flip all of them. So flipping the elements means changing its value from 0 to 1 or from 1 to 0. Basically what we have to do, minimum number of operations. We have to return minimum number of operations required to make all elements in nums equal to 1. If it is impossible, return minus 1. Means what we have to do, make all elements 1. Okay, you have to make all the elements in the array equal to 1. And you have to return minimum number of operations to do such such operations. Okay, let's see the example. You have given nums of array 0, triple 1, 0. Okay, now you can see you have to convert 3 zeros. You have been given 3 zeros. You have to convert them to 1 so that all the elements will become 1. So our first operation will be on 0, 1, 2. Our first operation will be on 0, 1, 2. Okay, This one, as you can see here, 0, 1, 2. It's 0, 1, 1. Now it's converted to 1, 0, 0, as you can see here. Now our next operation is on 1, 2, 3. This 1, 2, 3. Okay. Now it's converted to 1, 1, 0. Is that clear? So now next one. Now our next number is 3, 4, 5. Okay. As you can see, we have converted 3, 4, 5 to 1, 1, 1. Okay. So in this way, we have to perform the operation. Okay. Now our next input is what nums of 0, triple 1. Okay. In this, we have to make all the elements 1 by flipping 3 consecutive elements any number of times. Okay. So our array length is basically what 4. In this, our array length is basically what 4. So our possible flips can be 0, double 1 to 1, double 0. Okay. Flipping this element will change uh, triple 1 to triple 0. Okay. So suppose take an example. Wait a minute. Yes. So our nums is basically what 0, 1, 1, 1. So our first operation will be what? First operation will be on the first indices 0, 1, 2. Okay. 0, 1, 2. Is that clear? So for 0, 1, 2, it will be what? 0, 1, 1. 0, 1, 1. Okay. 2, what? It will be 1, double 0. 1, 0, 0. Means basically what? It will be 1, 0, 0, 1. Okay. Now our next operation is on what? 1, 2, 3. 1, 2, 3. Basically what? Double 0, 1. 0, 1. So it will be converted to what? Hmm. Not basically double 0, 1. Yes, yes. It will be, sorry, it will be 1, 1, 1. My mistake. It will be 1, 1, 1. Now it's converted to 0, 0, 0. Okay. Now next one. At first one, it will be at now we still have zeros at indices 1 and 2. Okay. And flipping them in this one, I am talking about this one. And flipping them the next group of three elements like indices 1, 2, 3 will make it triple 1, 0. Okay. What mode it make? Triple 1, 0. As you can see. Okay. So this will be our new nums array. Okay. So still we have the 0 at the last position. If we flip indices 1, 2, 3 first, it will be 0, 0, 0. 1, 2, 3 first. It will be what? 0, 0, 0, 0. Okay. So after flipping, it will be giving us all zeros. Okay. So we can't make it all ones. So we will just return what? Return -1. Okay. So this was the basic approach I have used here. Now let's talk about the code. I have taken n as the length of the nums array. Okay. Was operations equals to 0. Okay. I have run the for loop from 0 to n minus 2. Okay. If our nums of I is equal to 0, then we'll flip the element at index I plus 1 and I plus 2. Means flip the elements at I plus 1, I plus 2. Okay. Now I flip the element at I plus 1 and then at I plus 2. I have just flipped the elements. Okay. Now I'm incrementing the operations. Okay. Now I'm running another for loop from n minus 2 to n. Okay. If our nums of I is equal to 0. Okay. Then we will return just -1. Okay. And just we will return the operations. Mm, as you can see, yes. We will just return operations at last. So now let's try to run the code. Yeah, it's giving correct output. Now let's try to submit it. Yeah, it's been accepted. So friends, now let's move on to our next question. Okay, next question is basically what? Let's see. Hmm. Our next question is based on the earlier question only. It's just minimum operations to make binary array elements equal to 1. It's part 2. Okay, wait a minute. Yes, we have been given an binary array, okay, nums, and you can do following operation on array any number of times, possibly 0. You have to choose any index I from array and flip all the elements from index I to next of the array. Okay, what basically here I have done? Hmm. So as you can see here, we have been given an array nums nums equals to 0, 1, 1, 1. For example, so you have to flip all the elements next to the array. For example, I am flipping element at index 1 or uh, element at index, let's suppose, mm, let's suppose I am flipping the element at index 0. So basically the array will be 1 times 0. Okay. Now if I flip the element at index 1, If I flip the element at index 1, what it will be? 1, 1, 1, 1. Okay. And if I flip the element at index 2, basically it will be what? Index 2. It will be all 0, 0, 0, 0. Okay. If I flip the element at index 0, 1, 2, 3, index 3, flip the element at index 3. Yes. 1, 1. Okay. Now at last, if I flip the element at index 4, yes, it will be 1, 1, 1, 0, 0. Okay, so this is the basic approach we have to do in this. We have to find the minimum number of operations to make all elements. Yes, you can see here minimum elements in nums equal to 1. So here our minimum number of operation is basically what? Minimum operation is basically 2. Minimum operations to make all elements 1 is 2. Okay. Hmm. So in this example, let's talk about 0, 1, 1, 0, 1. So we will choose the first index 1, index 1. So sorry. We will choose the index 1. Okay, so it will convert all elements from index 1 to 0, 1, 0, 1. Okay, 0, 0, 1, 0. Now index 0, it has converted all elements. Then index 4. Okay, now at last the index 3. So in this, the minimum operations required are 4. But in the second one, you can see there are 3 zeros and 1 ones. So if you flip the element at index 1, all elements will be flipped to 1. Okay, same here only. If you choose the index, flip the element at index 1, from so all elements will be converted to 1. Okay, let's talk about the code. In this, I have initialized the operations to 0. I have initialized the operations to 0. Okay, and basically A is basically what? Expected value. It's basically the expected value. Okay, I have initialized the expected value to 1. Okay, now I am checking for num in nums. Means I am checking each element in the nums array. Num in nums. If my num is not equals to the expected value for each number, if it means if it matches the expected value, if it doesn't match, it means an operation is needed. So we increment the operations counter. Okay. After each iteration, we toggle expected value from 1 to 0. Okay. Or from 0 to 1. Just a simple thing and nothing else. Expected value will increment the operation. Yes. Wait a minute. Yes, incremented the operations to 1 and I have toggled the expected value from 1 to 0. This is used for the toggling expected value from 0 to 1. Okay, so now I am returning the operations. Return the operations just. Now let's try to run the code. It's giving runtime error, cannot access local variable operations. So what's the error here? Why it's giving error local variable operations? OPERATIONS. Yeah, what's the error in this? It's I have not done any typo error also then okay. I have not checked here if and num. No, I think my code is correct. Num is not equals to the expected value operations plus equals to 1. Expected value equals to 1 minus expected value. So we'll just return the operations. Return the operations. I don't know why it's giving the unbound local error cannot access local variable operations where operation plus equals to 1. Runtime error. Let's do the chat GPT. Last solution. I think this one is giving the error. Again, runtime error. What's the error here? Hmm, I don't. Yes, I've got the error. I've just done one thing. Uh, as you can see here, huh, I have unidented the expected value. Means I have toggled the expected value to under the operation. This one I have done. Okay, so we must have it here. and nothing else. Now it's getting submitted. Wrong answer. Okay, okay, wrong answer. What the hell is this going on? I have got the error here. Just because of that comment I have written, it's giving the out of bound and nothing else. As I have removed the comment, it's getting accepted. So sorry for the misconception. Okay, so thank you guys. Let's one time try to solve the fourth problem. 2 minutes are left. Let's try to read it. Yes, count the number of inversions. You are given an integer n and a 2D array. Okay, so requirement 2D array requirements where requirements of I equals to end and counter. It represents the end index and the inversion count of each requirement. So basically, we have been given an integer n and a 2D array requirements. Okay, so left count contains the end and right contains the counter. Means end index and the inversion count. A pair of indices I and j from an integer array nums is called an inversion if I less than j and nums of I greater than nums of j. Means a pair of indices I and j from an integer nums. अरे यार ये नीरज वालिया कहाँ से आ गया? Notifications are always disturbing. हाँ, so I and j from an integer array nums is called an inversion if I less than j nums of I greater than nums of j. Yes, if the indexes I smaller than j and the nums of I greater than nums of j. Okay, it's called inversion. Return the number of permutations. A perm of 0, 1, 0 to n minus 1 such that all requirement of I permutation of 0 to end of I has exactly counter of I inversions. Since the answer may be very large, return it modulo 10 to the power 9 plus 7. Okay. Mm, input we have been given 3. Our requirements are 2 comma 2 and 0 comma 0. The two permutations are 201. Its prefix are 201 is inversion 0, comma 1 and 0, comma 2. Okay. Prefix 2 has 0 inversions. Now what we have to do here? Okay. Mm, 120 prefix has inversion 0, 2 and 1, 2. Basically, I think we have to use hash map here for storing the values. Prefix 201 has inversion 0, 1 and 0, 2. And what prefix 2 has 0 inversions. Prefix 1 to 0 has inversion 0, comma 2, 1, comma 2. Okay. हम्म, करना क्या है maximum inversions. Okay, we have been given length 1. For example, length 1 permutations are 1. Valid permutations are 1. So it doesn't meet the inversion requirement. So the count is 0. And length 2, the permutations are 1, 2. Okay, okay. Dynamic programming approach to solve the problem of counting permutation which satisfy the inversion of requirement efficiently. So it basically the dynamic programming approach. Yet my level is I am yet to go till here. So thank you guys for seeing my editorial. Okay. So bye guys. Thank you very much.